Hi everyone, today we're going to talk about acid-base indicators. What is an indicator? It is an organic acid that has a different color in the acid form represented by HIN than the conjugate base form represented by IN-. So at equilibrium, the HIN reacts with water to form hydronium ion and the IN- ion. Now it will be a different color for the HIN than the IN-. When the pH is low, that means the hydronium ion concentration is high. Equilibrium lies to the left by Le Chatelier's principle, resulting in color 1 in the acidic region. And when the titration goes on, the hydrogen ion is decreasing and equilibrium is shifted to the right, resulting in the color 2 of the basic region. From Henderson-Hasselbalch equation, pH is equal to pKa plus log of IN- over HIN. Now we can use this equation because basically we have a buffer system with the indicator. Assuming color change is visible when the ratio between IN- and HIN is 1 to 10. Well, then you have a pH equal to pKa plus log of 0.1, which is pKa minus 1. Or when the IN- and HIN concentration ratio is 10 to 1. Now you have pH is equal to pKa plus log of 10, which is pKa plus 1. So for an indicator with a given Ka, the color change occurs over a pH range of plus or minus 1 from the pKa value. It will be good for us to remember that. Since pH changes rapidly in the vicinity of the equivalence point, the proper use or the correct use of an indicator would produce a color change at the endpoint near the equivalence point of a titration. If the ratio is exactly equal to 1, we get an intermediate color. If the ratio is greater than 1, we get the basic color. And if the ratio is less than 1, we get the color of the acidic region. For example, if you use bromothiamyl blue and it changes from yellow to blue color, yellow is in acidic region and blue is in the basic region. In between will be the green color. And we only use a few drops of indicator for your titration, as you know from experience, because the color change is very intense. Now here is a table of the more common indicators that we would use in our titration with their pH range of color change. With crystal violet, it is from 0 to 1.7 for the pH range, going from yellow to violet. With the bromophenol blue, the change is from 3 to 4.6 pH from yellow to blue. With the methyl red, it's 4.2 to 6.3, changing from red to yellow. With the bromothiamyl blue, changing pH from 6 to 8, yellow to blue. With the phenolphthalein, which we use all the time, pH changes 8 to 10 from colorless to a really pretty pink. And not too pink because we don't want to over-titrate too much. And then thymolphthalein, which has a pH range of 9.5 to 10.5, colorless to violet. And alizarin yellow R, which has a pH range of 10 to 12, yellow to red. So here is a color chart of the various indicators that I talked about earlier. Crystal violet, as you can see, goes from yellow to green to violet. And the bromophenol blue goes from yellow to green to blue. Methyl red goes from red to orange to yellow. And bromothiamyl blue goes from yellow to green to blue. Phenolphthalein, colorless to pink. Thymolphthalein going from colorless to violet. And alizarin yellow going from yellow to orange to red. So hopefully this is helpful when you looking up for the indicator and the kind of color change and the pH range that it covers. If we have a titration of 20 milliliter 0.1 molar HCN, which is a weak acid with strong base 0.1 molar NaOH, choose an appropriate indicator. So first we write the net ionic equation, OH minus and HCN to produce CN minus and water. Now at the equivalence point, both the weak acid and the strong base, which is 2 millimoles, are all being consumed, therefore producing 2 millimole of the salt sodium cyanide. Now this sodium cyanide will hydrolyze in water at the equilibrium to produce hydroxide ion according to this equation. And we know that the cyanide ion has 2 millimole in a mixture of 40 milliliter, which is 0.05 molar. So hydrolysis of the salt produces hydroxide ion, and we're going to use Kb value, which is equal to x squared over 0.05 molar. And x is calculated as 8.9 times 10 to the minus 4 molar. And this is the hydroxide ion concentration. Therefore, pOH is 3.05, and pH will be 10.95 at the equivalence point. Since the pH is 10.95, we want to pick an indicator that has a range covering this 10.95, and alizarin yellow will be the best one to use because it has a pK value of 11. So plus or minus 1 is from 10 to 12 that covers the pH of the equivalence point of 10.95. Practice problem number 2, we have a titration of 20 milliliter of 0.1 molar ammonia with 0.1 molar HCl. Find the appropriate indicator. Now we write the net ionic equation of hydrogen ion with ammonia to form ammonium. At the equivalence point, both the hydrochloric acid and the ammonia are used up. So we make the ammonium chloride, the salt, which is 2 millimole, and it will hydrolyze in water to form hydronium ion. So the concentration of the hydronium ion is actually the ammonium ion. The ammonium ion, not the hydronium ion, is 2 millimole over 40 milliliter, which is 0.05 molar. And using the K value to solve for it, we now determine the hydrogen ion to be 5.3 times 10 to the negative 6 molar, and pH at the equivalence point is 5.28. The methyl red is the appropriate indicator to be used because it has a pK value of 5.2. That means a plus or minus 1, we go from a range of 4.2 to 6.3, which will cover the equivalent pH at 5.28. So we change from basic yellow color to red color in the acidic region upon the completion of the titration. Summarizing what we have learned today, we learned that the indicator has different colors, be it in the acidic region or the basic region. We learned that it is important to choose the correct indicator so that a color change can be produced at the endpoint very close to the stoichiometric equivalence point. That an indicator is effective in producing color changes over a pH range of pKa plus or minus 1. We also looked at some common indicators for acid-base titrations. Finally, we calculated the pH at the equivalence point so that we can choose the correct indicator to signal the endpoint. I hope that you have found the video helpful. If you like it, please give us a like and please subscribe to our channel. And I hope to see you again real soon.